Hello, welcome to tutorial 2 on correlation. We're going to start with looking at the general steps involved. I'm starting with the tutorial page, going to the correlation notes, and this tutorial will introduce you to statistical and graphical examination of linear relationships between two variables, and we will use both non-parametric and parametric techniques. This tutorial builds on understanding of univariate descriptive statistics and graphing and univariate levels of measurement. We can then use non-parametric and parametric linear correlational analyses in SPSS, and we'll place an emphasis on both visualizing the data and getting the correlational statistics. This tutorial also involves interactive correlation guess exercises for scatter plots to help you make an intuitive connection between what you see in a scatter plot and the correlational statistics. And finally, we'll look at the effect of outliers and restricted ranges in correlational analysis. Now you can try this 10-item correlation quiz yourself as a form of review, and what I'll now describe are the general steps that you should consider when you're approaching a correlational analysis. The general question that we're asking is, to what extent are two variables related or dependent, or to what extent are they unrelated or independent? So the steps involved are to firstly determine the level of measurement for each of the variables. Once you know that, you can then use a guide or a table, which I'll show you, to work out what is the appropriate visualization and what is the appropriate statistic. We would then seek to understand the univariate properties of each variable through using descriptive statistics and graphical displays. If necessary, we may then need to recode one or more of the underlying variables. Then we can obtain a bivariate graph, such as a clustered bar chart or scatter plot, to visualize the relationship between the two variables. And if we're dealing with non-parametric data, we can get bivariate descriptive statistics, in particular contingency tables, which provide the frequencies for each level of variable. Sixthly, we can get the correlational statistics, and depending on the level of measurement, that could be phi or Kramer's V for nominal by nominal data, point by serial for dichotomous by interval or ratio data, Spearman's rho or Kendall's tau for ordinal by ordinal data, and probably most commonly the Pearson product moment correlation for interval ratio by interval ratio data. Last but not least, in fact probably the most important, is to interpret and draw conclusions from your analysis of data, and to present that in easy to understand language that indicates how well you understand what the data mean.